Alright, so let's start part 3 of this tutorial. First thing I want to do is, you see this run button, which is associated with a macro, the bound, what's the name, the bound array movement. And let's make it a pause. Let's give the pause function, okay, a stop function. So we can go here and type pause, okay, and let's make it a little bit bigger. So run pause, and come here to the this macro, and you see this for loop with s. Let's change it into a while loop. While, let's put in this cell on the state of the simulation, W28, on or off. So let's say while W28 is equal to on, let's say we change the value of W28 to off, okay. Okay, let me see what this is. So Control X. Before we do this, we need to say if Control V W28 is equal to off, then W28 is equal to on, okay, else W28 is equal to off, and if. So what we did here is we added a section in this macro at the beginning of everything before we even start running through the operation, which means when we start, if this value here is on, it toggles it to off. If it's off, toggles it to on. So it changes the value of this from on to off, from off to on, back and forth, okay. And then we also put while. If this is on, the macro will run again. We will end with while end, which is when, okay. And let's see how it works. Set, okay, run pause. You see, clicking on this button, you get W28 changing from on to off, and on, off to on. When it's off, it stops it. When it's on, it goes ahead. Let's say set, and then we can run it again. It's nice to add, when we reset, when we set this, to add this statement in the reset macro, okay, copy, and let's put it here too. Okay, so if this runs, then hitting set, it will stop the array. You see, you watch this cell. If you hit set, it will turn it off. And also run, pause, you can run or pause, okay, and set. Even if it runs, you can stop it from set and reset it, of course. If you don't want to reset it, you can just pause it and continue the simulation later, okay. Run, pause, set. Another nice thing to do is insert here a cycle number, but let's do this later. For now, let's just analyze what this macro does, okay? Forget about this on-off thing. Let's scroll till we have the rest of the macro in the field of view. So on this side, on this spreadsheet here, I made two little 7 by 7 arrays, atoms and atom change, that just to illustrate what happens in this macro. Okay, so let's say we have an atom here at 2, 2, okay? I is equal to, j is equal to 2, and let's highlight this in red. So we manually go through a little bit through this macro to understand how it works. So let's suppose we have 0 everywhere, and here there's a 1, okay? So there's one atom in the array, and the array is not 20 by 20, it's 7 by 20. It's not 21 by 21, it's 7 by 7, okay? Start with 0 and ends to 6. If you look at this macro, what happens? You generate two random numbers between -1, 0, and 1. Let's say this is 1, m is 1, let's say n is 1, okay? And after you generated this clear atom change is cleared. Everything is 0 here. Why? How do you know? Because here I put I inserted a clause that goes after each cycle. It clears the change matrix, so it's 0, and so it goes through both of these nested loops, and then continues with the first one, second one, goes back to the first one, second one. So what you see here, these two arrays, atoms and atoms change, are a snapshot during one iteration. After the iteration is done, you go to the next iteration, okay? So let's say you have in 2, 2, I is equal to 2, j is equal to 2, you have a 1 here, one atom, everything else is 0. If you read this, you generate two random numbers, which let's say they are 1, 1. 1, 1 means movement like this, okay? On a diagonal down, right and down. So after you do that, you verify if the new position of the new position that you want to move the atom randomly is within the bounds of the array. If it's not within the bounds, continue running the loop, this do loop, till you have the new position in the bounds. After that, you exit the loop. You have two values. In our case, m is equal 1, n is equal 1, and do this. Atoms change of 2, 2 here, because this is 2, 2, is equal to atoms change -1. So you go here and put a -1 because it was a 0 before. And also in the new location, which is 1, 1, added 1 to both coordinates, you put a +1, okay? Then what do? You do this for all these things, but since we only have, you see there's a clause here, atoms jy if is greater than 0. Everything else is 0 except this. So we already finished this. Then we go here and do what? The new atoms array is the old atoms array plus atoms change. So here you add the -1 and the 1, and you will have a 0. And then here you add a 1 and a 0, you have a 1. So what you did here, you move the atom on diagonal going to the right and down. Let's say you have here m is equal to 0 and n is equal to -1, okay? So after you finish the previous operation, you come and clear this array. So you clear, and the new array is 0. Everywhere is 0. You see nothing in the pixel is 0, okay? And you go back here, and again in this location right here you put a -1. You set this to -1 because of this statement here, okay? In the location where you have an atom, you put in the same location, but in atoms change matrix, you put a -1. In the new location where you put m is equals 0, okay, and -1, so here, right here, you add a 1, okay? And then you come here, what do you do? You add them together, add this matrix and this matrix, and obtain the new atoms matrix. So add 1 with 0 here, and you get a 1. Add a -1 and 1, you get a 0, okay? So, and then what do? You clear this all with zeros and put it here. Now everything will be filled with 0 in the atoms change matrix. Now let's fill this with red. So the atom moves this way in conformity with m is equal 0 and n is equal to -1. Now let's say m is -1 and n is -1, and again during the same operation you display the atoms. So where atoms, the new atoms jy is greater than 0, you color it in red. The rest you color it in yellowish. So here where you have a 1, you color it in red. Okay, now this is -1, -1. -1 is this location. In this location you will put a +1, okay, in the atom change, so 1, and in the original location you put a -1, okay? And now you add them together, and the new position of the atom is here, so it moved up and left, and here you have a 0 after you add this array with this array, okay? You get this. So this is the new location. So I showed you in each of these stages, what you see here is one iteration of this whole macro. So this is the same thing after you finish this iteration. So what happens is you change atom change matrix based on these two statements here, okay? These two statements, and then you add this and this, obtain the new atoms, clear this atom change, put it here, and then use this offset in random indices m and n to find the new position of the atom, okay? So that's how it works. This moves here, then it moves here, and then it moves here, okay? So then it moves yeah, it moves here, see? Alright, this being said, let's add a polymerization. How do we add polymerization to this? Okay, I suggest we do the following. After we calculate this, we calculate the atoms atoms matrix, the new atoms matrix. We say this: if, okay, atoms of ji greater than 1, which means 2 or more, we have a polymer, okay? If it's smaller than 1, we cannot form a polymer, but if during the iteration of this macro, in a position you have atoms in one location, the atom's value is greater than 1, you form a polymer. So what you do is you do B2, okay, let's copy this, okay, B2 offset of this, we will mark down the polymer, okay, in the cell, we will write down, we'll transfer the value. How do we find how many polymers? If it's 2 atoms at one time, you have 1 polymer and no atom remaining because they are consumed in creation of the polymer. If you have 3, again, you remain with 1 atom and 1 polymer. If you have 4, no atom remains but 2 polymers. Okay, int. So if we have a certain number of atoms, we can divide the number of atoms by 2 and find out the number of polymers. So during each iteration, we write down as a number in the cell the number of polymers formed. And if they form more, we add to what is there. So if it starts with 0, let's say you're at the beginning, you have no polymer there. This is 0, okay? B2, in that location you have 0 polymers. You will add how many atoms you have there. If you have more than 2, you divide it by 2, and this truncates the value, so you get an integer number. Okay, so this will print the number of polymers in each cell. Also, I would suggest, let's use this. Surround each location of the polymer with a border, okay, a little border, okay. So actually it's not there, it's here, okay. So we surround it with a border. And also, let's say atoms. Also atoms of Ji is equal to the remainder of the number modulo 2. Okay, so what after the polymerization which happens here, you need to divide the number of atoms in 2 if they are more than 2. You see, if more than 1 atom, so you have 2 or more, then you print a number of polymers which are equal to the number of atoms divided by 2, okay. And of course there's a remainder. The remainder is what is there, okay. So and if, okay. And also let's do this in the set array, okay. We put here, we insert this statement, we delete the borders, okay, none. So while you run the set array, you delete the borders, okay, and also you clear, okay, you clear this. clear content. Okay, let's see, clear contents, clear contents. Okay, now let's see how it works. We go back here, set it, and run. Oh, there's an error here. Atoms. Let's try again. Set. Okay, it doesn't like that we had an error. We need to stop the macro. And set and run. Okay. So you see it's generating polymers now. Let's stop this, set it. Let's put this 2. Okay. Let's set this spacing to 2, set, run. Okay. So it's generating polymers. If we stop this, okay, you see here it has 2 polymers, 3 polymers, 1. Most of the places you have 1. Let's go 1 here. Set, run. Okay. So it's generating polymers which have a border, and also the number of polymers in each cell is known. All right. So let's put 5. Okay. Set, run. So you can see how it's generating. Slowly they meet and they vanish. They combine together and they form a polymer. All right. So I would say another thing we can do here is we can print the number of the cycle, also print the cycle during the display right here. Let's say cycle number. We'll print it here in W31. Actually, let's not do this. Let's do it right here. W23. Let's say 1. Okay. So in first in the set array, we put W23. We set W23 is equal to 0. Okay. And here copy Control V. W23 is W23 plus 1. So each time it runs our chemical macro runs through the whole thing, it adds 1 to each, increments this W23 by 1. Okay, let's see how it works. Set, run. Okay, you see here this W23 shows how many reactions, let's stop this. Set, 1, set, run. Okay, so you have the cycle number, the atom spacing, and the state of the array, which is on, off. Actually, let's move this button here next to the indicator, the on-off indicator. So you can run it, you can set it, you can display the cycle number, and you can figure out yourself what you want to automate. What I would automate, what I would make it even nicer if I were you, I would introduce a variable max array, let's say, and instead of these 20 everywhere, put max array. Okay, so you can generate arrays of different sizes at a click of a button. So when you put a max array, let's say is 10, you get a much smaller. You can make 50, you know, change this to 50, and then again there will be a statement here in the reset. Okay, reset is here, where you take the value, say max array is equal to whatever you put here, say in this case 21, okay, or 20, or 10 or 50. So you can do that too. Let's run it again. Run. Okay, it runs pretty well. Okay, I will do another installment in a day or two, showing you a few more tricks you can play. Thank you for your attention.